Okay, so in this video we're going to continue looking at second order ODEs with two distinct real roots. In the last video we used a lambda function and we set the right hand side of the equation equal to 0, so we made it homogeneous, and this gave us our fundamental solution. In this video we're going to take a look at the particular solution, which is for a non-homogeneous equation. And from the fundamental solution and the particular solution we can find a general solution, which is simply the first one, the fundamental solution, added on to the particular solution. So we'll call it x subscript fundamental solution plus x subscript particular solution. And once we've done all this, we can finally solve an initial value problem. So we would have to have some information about the system's position at, for example, time 0 and the first derivative at time 0 as well. And once we have this information we can evaluate the constraints so we can find our constants. And these are the 4 steps that you need in order to solve any second order ordinary differential equation. So let's take a look at an example. Okay, so this example is the same as the one we saw in the previous video, however the right hand side of the equation is not equal to 0 anymore, so we have a non-homogeneous equation this time. So what do we do? So first off, if we look at the right hand side of this equation we can see that this is a superposition of two different values. So therefore our particular solution is also going to be a superposition of these two values. So what does that mean? Well, here's our first one, and here's our second one. So what that means is we're going to have two separate equations that we need to solve. So we're going to need to solve x prime prime plus 2 plus 2x prime minus 3x is equal to 3e to the 2t. And we're also going to have to solve the same equation is equal to 2 times the sine of t. So let's concentrate on our first equation first. Our particular solution, x particular, let's call it particular 1 of t, is going to be equal to, so the right hand side of this equation is 3e to the 2t, so we need some value that when we differentiate it we cover all of the possibilities. So our general equation is just going to be some unknown constant a times e to the 2t, because when you differentiate e to the 2t with respect to e, you're just going to get the same thing but with a different coefficient in the front of it, using the chain rule. So this means that the first derivative of our first particular equation, if we take the first derivative with respect to t of this here, we're going to have 2 times a e to the 2t. And if we take the derivative again, we have the second derivative of our first particular equation is equal to, well, if we take the derivative of this, we're just going to have 4 times a e to the 2t. So then once we've calculated these values, we can take our particular solutions and input them into the original equation. So on equation 1 here, where we have x prime prime, we will replace it simply with x prime prime subscript p1. So we're replacing it with our particular solution. So here we have the second derivative of x, however we'll have our particular solution here. So the second derivative was 4a e to the 2t, so we have 4a e to the 2t plus 2 times the first derivative. So our particular solution of the first derivative was 2a to the 2t, so we have 2a e to the 2t, sorry, minus 3x. So if we take our particular solution for x was 3 times a e to the 2t, so we have minus 3 a e to the 2t is equal to still 3e to the 2t here. And now we can simplify this quite trivially and find that a is going to be equal to 3/5. So therefore, our first particular solution, P1 of t for this specific problem, is equal to a, which is 3/5. e to the 2t. And as I mentioned at the start of the video, since the right hand side of this equation is non-homogeneous and it's a superposition of two different values, that means we also need to find our second particular solution so that our solution is also a superposition. So number 2, we'll call it x particular 2 of t is equal to our general equation. Since when we differentiate sine we get a cosine, our general equation for x particular 2 of t is going to be a superposition of sine and cosine states. So we're going to have, in no particular order, a times the cosine of t plus b times the sine of t, where once again a and b are constants that we need to calculate. So if we differentiate that once, we get cosine differentiates to minus sine, so we have minus a times the sine of t, and sine differentiates to cosine, so we have plus b times the cosine of t. And then if we differentiate that again, so sine differentiates to positive cosine, so since we have a negative here, that stays there, so we have a times the cosine of t, and cosine differentiates to negative sine, so we have minus b times the sine of t. So once again, if we substitute our particular values into the original problem here, that will give us, so we have 1 times the second derivative, so we have minus a cosine t minus b sine t plus 2 times our first derivative value of the particular solution, so we have minus a times the sine of t plus b times the cosine of t minus 3 times our zeroth derivative, so we started with a cosine t plus b sine of t, and still is equal to 2 sine of t. So now all you need to do really is just to be careful with your sine and cosines and tidy this up. So this will move to minus 4a times the cosine of t minus 2a times the sine of t plus 2b times the cosine of t minus 4b times the sine of t is equal to still 2 times the sine of t. So now that we've got a bit more space, we can continue evaluating this function. And we could divide this all through by 2, however we'll just leave that till the end. So if we evaluate first off the cosine of t's, you can see that we have minus 4a plus 2b is equal to 0. And if we evaluate the sine of t's, we have minus 2a minus 4b is equal to 2. And all we're doing here is evaluating like terms, sometimes known as exponential evaluation or coefficient analysis, but all we're doing basically is looking at the cosine and the sine terms and splitting them up in order to create two separate equations. And now we can solve these two equations using simultaneous equations. So this equation will go to minus a minus 2b equal to 1. So therefore a is equal to minus 1 minus 2b. So then we can use our value we found for a here and plug it into here. So we have minus 4 times all this will be minus 4 times minus 1 is just positive 4. Minus 4 times minus 2 is plus 8. And then plus another 2, so we have plus 10b is equal to 0. So therefore b will be equal to minus 2/5. And then we can plug our b value into this equation to find our a value. So we have minus 2a minus 4 times minus 2/5 is equal to 2. Therefore a must be equal to minus 1/5. So when we bring all this together, that means that our particular solution of the second part is going to be equal to, we said a times the cosine, so minus 1/5 cosine of t plus b, so minus 2/5 times sine of t. And now we have the particular solution of both parts of the right hand side of the equation. Okay, so now that we have both parts of our particular solution, we can finally bring it all together. So our final solution, x of t, this is equal to our fundamental solution, which we found in the previous video, plus our particular solution, which we found in this video. So therefore now, we can conclude our x of t is equal to, and we saw in the last video that our fundamental solution was some constant c1 times e to the minus 3t plus some other constant c2 times e to the t plus, and we need both parts of our particular solution that we found here and here, so plus 3/5 e to the 2t minus 1/5 times the cosine of t minus 2/5 times the sine of t. And this is known as the general solution, so we can call this x subscript g. However, some of you might notice we still have unknown constants in this equation. So like I said at the start of the video, there are 4 steps, and so far we found our fundamental solution, which we found in the previous video. We found our particular solution, which we found in this video. However, in order to find our final solution, I said at the start that we need to solve an initial value problem. So if we knew, for example, that x of time equals 0 is equal to some value and the first derivative at some time is equal to some other value, we could calculate our c1 and c2 values. So that's what we're going to do in the next video. As always, if there are any questions or comments, please feel free to ask them in the comments box below. Thanks for watching, and I'll see you in the next video.